Okay, the next couple of sections deal with converting one measurement of concentration to another. Today we're going to go back and forth between molar fraction and molality. In order to really get a handle on this, we need to have the four formulas down for our concentration. Percent solute, amount of solute over the amount of solution times 100. Molar fraction, which we call X sub whatever, is the moles of the substance that we're looking at, which would be our subscript here, divided by the sum of all the moles of the substances. Molarity is the moles of solute divided by liters of solution, and molality is moles of solute over kilograms of solvent. Little distinctions of the differences, and this is what causes people the most amount of grief. So you need to get those down pretty well. Okay? So let's take an example here. So what is the mole fraction of NaClO2 in a 0.750 mole per kilogram solution of NaClO2? So let's go to the next page, 0.750 mole per kilogram of NaClO2. We're trying to find the mole fraction of NaClO2. That's our goal. So in order to understand this, then we need to write out what the formula is for molality based upon the numerical value of 0.750. And what this means then is that you have 0.750 moles of NaClO2 for every 1 kilogram of NaClO2. Okay? So, in finding the mole fraction of NaClO2, this is going to be equivalent to moles of NaClO2 over the sum of the moles of NaClO2 and the moles of H2O. Okay, why I put the solute down twice? The solvent here is water, so this really should be H2O here. Must be getting late. All right, so what I'm going to have to do next then is, first of all, plug in what I know. And since I know the number of moles of NaClO2 in this ratio right here, then I'm going to put 0.750 for this and 0.750 for this. So now the question is, how many moles of water do I have? Well, in this ratio I have a kilogram of water, which is equivalent to 1,000 grams. And I'm going to convert that to moles by going to the periodic table and finding out the mass of 1 mole of water. And that turns out to be 18.0 grams. So when I do the math on this, this gives me 55.6 moles of H2O. So that's going to go right there. So then I go through my calculations for this, which I've already done on the script, and I get 0.133. So that's all there is to that. Now we're going to go the other direction. In this case, I have 4.25 moles of sodium hydroxide dissolved in 10.5 moles of water, and I want to find the mole fraction of NaOH and the molality of that. All right, so let's get that written down here. Go back again, and I've got 4.25 and 10.5. Okay. 4.25 moles of NaOH and 10 moles of water. Well, the mole fraction's pretty easy. Since you already have moles, that's just a basic plug and play problem here. So put X sub NaOH, since we're just looking at the NaOH and not the water as an entity upon itself. This is going to be the moles of NaOH, which is 4.25, over the sum of 4.25 plus 10 moles. Moles cancel out. And we've done the work over here on this right here, and we get 0.288. All right, so that's pretty nice. All right, the next, now I got to do the molality. M is going to be equal to moles of NaOH over kilograms of water. Well, we have the moles of NaOH, that's 4.25 moles, so that's easy enough. But what we don't have is the kilograms of water. But we are given 10 moles of water. We can change that to grams by multiplying by 18.0 grams per mole like we did before. That relationship, although we had it flipped around for the previous problem, that gives us 180 grams. And we need to change that to kilograms, so we multiply that by 1 kilogram over 1,000 grams, and then gives us 0.180 kilograms. And now, we can divide these two out, 0.425, 0.180, and that will give us our molality. And again, I've done that on the script, and turns out that that is 22.5 moles per kilogram. Not too bad. What I need for you to do then is do pages 547, 548, do problems 51 through 54. Okay? Good luck.